right, so today we're covering the surface area and volume of prisms. Prisms are unique because we actually categorize prisms by their bases, okay? So a prism will always have a base. Well, a base can be, theoretically, it can be any polygon. It could be a rectangle, it could be a triangle, it could be a pentagon, a hexagon, an octagon. You can have all of those types of prisms. Now, if it's an octagonal prism, that means not only does it have the top and the bottom bases, but it would have 8, count them, lateral faces. That would be somewhat of a nightmare, okay, to do when we're finding surface area, and unnecessary, okay? So to avoid any type of torture in the honors pre-algebra class, we're sticking with the 2 basic ones. Triangular, how many sides does a triangle have? 3. So because it has 3 sides, it will also have 3 lateral faces. Now, we would calculate surface area of a triangle the same way we would do an octagon, okay? Except it's the same theory, it's the same concept. You're learning it without just tons and tons of extra work. And then a rectangular prism, how many sides does a rectangle have?
4.
So, guess, all the lateral faces, okay, will kind of go hand in hand with that as well. All right, now a rectangular prism, you'll see in a minute kind of how it looks. All right, so we do have some formulas. And then volume of a prism, we're going to cover volume actually in part 2. Of our lesson, but there's your formula as well. There's actually another formula. I like this other formula. I'll probably use this one. Volume equals length times width times height. I like it because it more closely aligns with the surface area. Don't you see the length and the width and length and height up there? Okay, so volume, okay, length times width times height kind of aligns a little bit more closely, okay? At least with the rectangular prism. All right, so volume of a rectangular prism, this is the formula that we would follow. Now, for a triangular prism, we would follow area of the base times the height for volume, but we'll get to that in part 2. All right, just so you have those formulas. Everybody good? Okay, so 2 examples we're covering today. In the first example, we're doing rectangular prisms. In the second example, we're doing triangular prisms. That's it. 4 problems, and we're done. I know it's like right before a holiday weekend. We've got our event tomorrow. We're really excited. But 4 problems. We can do 4 problems, can't we? Yes. Can we do 4 problems? Yes. Okay. So, yeah, we can do it. Here's our formula. I want you to write it next to the first rectangular prism. S equals, hold on. Let me start off with this, okay? I forgot I did this first. All right. We do need to identify which dimension is the height, which one's the width, and which one's the length. So, and it kind of depends on how the prism is turned. And theoretically, some of these dimensions are interchangeable because we're just multiplying. But obviously, we know that 6 would be what?
Height.
The height, okay? It's tall. And then 3, usually the width is the distance like across the front of a figure. That would be the width. So 3. And then 5 would be my length. Okay? Now, if you said 3 was the length, if you flipped them, you would still be okay. You would get the right answer. All right? Because we're multiplying. All right, so now here's our formula. Let's try to say it together. S equals 2 times length times width plus 2 times length times height plus 2 times width times height. That is something that you will have to have memorized. Now, you'll notice the more you practice these, you're going to fall into a rhythm, and you also can go back to the figure and you can see which sides you're finding the area for. Okay? Okay, so 2 times the length. So what's the length? 5. What's the width? 3. What's 5 times 3? 15. So does everybody see where I got 15? I multiplied the length times the width. Okay, so now the question comes into play, why am I multiplying it by 2? Well, notice that the length and the width make up this bottom side of the prism. Do you guys see that? Well, for a prism, especially rectangular, if there's a bottom, there's also a matching top side. So that's why you're multiplying it by 2, because basically what you're saying is if the bottom area is 15, that means the top area is 15, so I can multiply it by 2 to find both faces. All right, do you see what I did there? Okay, so let's do the next one now. Plus, well, what's 2 times 15? Let's keep, okay, 30. So I've got those areas, top and bottom. Now let's do 2 times the length, which is 5 times 6 is 30, okay? Now, again, if it was 5 times 6, let me change my color here. If it was 5 times 6, do you see how it's this side face right here? And then it would have a matching side face over here on the left side. So by multiplying it by 2, I'm saying I'm finding both sides there. Okay, do you see that? Does everybody see why I'm multiplying these by 2?
Yeah.
Because if I find one side, then it has another side that's matching. So when I multiply it by 2, I'm finding the area of both. So that's 60. Now I'm going to do 2 times the width times the height. 2 times the width times the height, which is this front face right here. The width times the height. So what's 3 times 6? 18. And then if it's the front face, it's also the back face. So 2 times 18 is 36. So now I found all the sides. 2, 4, 6 sides here. Okay? And 30 plus 60 plus 36 gives me the surface area of the rectangular prism. All right? Okay, so not so bad. Now, it looks kind of fancy and complicated, but you can see that we're just finding the areas of all of the sides and then adding them together. All right, so I want you to do the next one on your own. Okay, I want you to do the next one on your own. And somebody asked, you know, is the height and the width and the length always going to be more or less in the same location? The answer is yes on a rectangular prism. You don't have to worry about that. Triangular, we have to be a little more careful, and we'll talk about that in just a minute. Okay, wait, where did the first thing go? That was weird. Okay, so S equals 2 times LW, which is 8 times 8, which is 64, plus 2 times LH, which is 40, plus 2 times 40, yep, WH. Okay, so yes. All right, so now 128 plus 80 plus 80 again gives me 280. All right, who got it? Anybody get it? Okay, very good. Okay, so for triangles, remember what it said for surface area of triangular. Areas of bases, because for the triangular prism, how many bases do you see?
1. Too many.
Top and bottom. You see top and bottom, don't you?
Yes.
Okay, so I'll just highlight it real quick. All right, we have the top triangle and we have the bottom triangle, and they are matching. Okay, so I'm going to find the area of those triangular bases, and then what shape are my faces? What shapes are these?
Squares. Rectangles.
They're rectangles. And then I also have a back. Don't I have a back to that? Okay, back there. Okay, so here's the thing that we need to talk about, though. We find the area of a triangle, A equals 1/2 base times height. However, I'm given 3 dimensions. Do you see that 5 up there at the top? That means that's this back side back here. So what you need to decide is, okay, which one is the base and which one's the height. More specifically, which one is the height, okay? Because, do you see how there's a right angle box right here?
Yes.
Okay, This is very important, and it helps us figure out which one, either the 5 or the 4, is actually the height. When there's a right angle, the side opposite the right angle. Now, this is something you may not have learned yet, and the book kind of expects you to know. So that's why I'm telling you now. The side opposite the right angle is something we call the hypotenuse. Does that name sound familiar to you?
No.
Okay. So, on Tuesday when we go over this again and I say hypotenuse, you'll say, you said that on Thursday. Okay? So, for the hypotenuse, here's what it is, guys. It is never the height. And think about it. All right? I'm just going to give you a right triangle. Okay, if I have a right triangle, and assume this is right because it might be a little off. It's kind of hard. Well, that's really bad. Okay, close enough. All right, assume that this is a right triangle. Oh, goodness. This is getting botched. All right, think about it this way. Now, this is a little more obvious, but again, it's a right triangle on the bases also because there's that box there in the corner. So the slanted side, which is opposite the right angle, let's say again, okay, so it's 5, matching the triangle in the problem. That can never be the height, the slanted side of the triangle like that. Do you see that now? Okay, that's never going to be the height. So if you were, the mistake that you can make is, if you were to plug in 5 for the height over here, you're going to get the answer wrong. You can never use the hypotenuse for the height of a triangle. How do you know which one's the hypotenuse? It's opposite the right angle. Okay? Does that make sense?
Yes.
So now you can find the area of your bases. All right? You say, well, what if I confuse 3 and 4? Well, that doesn't matter because you're multiplying everything anyway. But if you plug in the wrong value, if you put in the hypotenuse, which is not the height, look at the diagram that I just drew. That slanted side is not the height of the triangle. All right, are y'all following me? Okay, all right, so now that we're clear on that, we can find the area of our bases. So 1/2 the base, okay, the base of 3 times the height of 4. All right, so what's 3 times 4? 12. And what's half of 12? 6. Okay, so area is 6, but remember, how many bases did I have? 2, top and bottom, right? So I could kind of flip it over on the other side if I wanted to. There are 2 bases, so what do I need to do with 6?
Times 2.
Times it by 2, because 6 is the area, say, of the bottom, but if it's the area of the top also, I can multiply it by 2 to get the area of my bases. Now that we've found the area of the bases, we need to find the area of our 3 lateral faces. How do I know there's 3? Because there's 3 sides to the base. Okay? So for the green lateral face, and so that's what LF stands for, lateral face. I'm going to find the area of my lateral faces now. So for the green lateral face, what's the length? Or the length times the width? What is it?
It is 6 times 4?
No, for the green one.
Oh.
For the green one right here.
3 times
What's the height on it?
5.
6. And what's the width on it? 3. So 6 times 3. You see that? All right, so 3 times 6. All right, now what about your blue one? No, it's not.
4 times. Oh, it's 4.
Yep. Your blue one over here is 4 times 6. So you can't expect for a triangle, triangles can have different side lengths. So these lateral faces will not have the same measurements. For the blue lateral face, what is it? 4 times 6. Okay? Now for the back lateral
5 times
face.
6.
Do you see this 5 here? That's where the 5 comes into play because the 5 tells me that that is the width of my back face that also has the same height of 6. So 5 times 6 gives me the back side. All right, now I need to do my multiplication. What's 3 times 6?
18.
18. What's 4 times 6?
24.
What's 5 times 6?
30.
Okay, and now to find the surface area, I add everything together. 30, 24, 18, and 12. Okay, and that's 84 meters squared. All right, so we just add everything together, the area of all of our faces together to find the total surface area. All right, and that's where we're going to stop for today for part 1.